Welcome back. This is Mr. Hassan's Maths channel. I'm now going to go through the June 2024 International A-Level Edexcel Pure Mathematics P4 paper. And this paper that I'm going to go through, I'm not going to go through it in one video. I'm going to take separate videos for each question. Maybe some questions I might split up into different parts, depending on the topics that they are. And I'm going to also save those videos in playlists. One playlist will be for this particular paper, all the questions in this paper, and the other playlist will be the topics that that particular question is from, or those particular questions are from. And I'm going to take this as a opportunity to support my students' learning. I'm not going to just, copy the mark scheme. I'm going to try to explain some concepts behind certain things, and I'm going to talk about some issues that students have, common mistakes that they make, keeping those things in mind as I'm going through the questions. So it's not just I'm going to do like a quick walkthrough. I'm going to actually try to explain things in a bit of detail, which might not suit some of you for what you're looking for, but just to give you a heads up, that's what I'm going to do. All right, so now, question number 1. Here we have an integral that we have to evaluate. So to find the integral of x cosine 3x with respect to x, and the limits that we have to find them, that the value of the integral for are between 0 and pi over 6. And we're asked to give the answer in its simplest form. Now we could just type this in our calculator and it will give us an answer. It might not give us an answer in an exact form or form that is required, but it will give us an answer. So it's not something which, it says here very clearly, solutions relying entirely on calculator technology are not acceptable. So you have to show some method, some steps. Now, when you have something like this, like x times cosine of 3x, and you want to integrate this with respect to x, right? A lot of people get confused. Can I use reversing the chain rule? Okay, can I use reversing the chain rule? Now, in this case, we can't use reversing the chain rule, because the chain rule is when you have a function inside another function. It's like you have a function, and inside it you have another function. So g of x is inside f of x. And if that is multiplied by some constant times the differential of the function inside the first function, then you can reverse the chain rule and integrate. Now in this case, the main function would be like cosine of something. Cosine of something. So that would be like your f of x. And the g of x would be 3x. Now if you differentiate 3x, you don't get something which is k times x. You just get k. Just get a constant. So if there was a constant times cosine of 3x, then you would be able to reverse the chain rule. And that just becomes like a normal type of integral. But for example, if this was cosine of 3x squared, not cosine squared, but cosine of 3x squared, then we would be able to reverse the chain rule, because when you differentiate 3x squared, we get 6x, which is, you'll have a constant times, the product of the main function. But in this case, we cannot do that because of that reason. If you differentiate the part that's considered inside the function, it doesn't give us a term in x. It gives us a constant. It's not the right order. So we cannot reverse the chain rule. So we have to find another method. And here we see that there is a product of two separate functions here. Okay, so what we could use is integration by parts. Now there is a method which is integration by parts basically, but just set out in a more user-friendly manner, you could say. Okay, and it's called the DI method. The DI method. I'm going to use that. I'm also going to show you the traditional way of integration by parts, and you'll realize it's the same thing basically. So we want to integrate between the limits of 0 and pi over 6 x times cosine of 3x with respect to x. Okay, with respect to x. Now, we've got two products of two separate things. So you have x is one product and 3x is another. So you have like x multiplied by cosine of 3x. Now, we want to choose one of those two to go under the D column. The D column means that's what you're going to be differentiating. And the I column means that's the thing you have to be integrating. Now, you have to always prioritize the D column. You have to put the expression that differentiates and breaks down to something simpler in the D column. Okay. Now, people use different types of, what they're called again. Well, basically, they say liate or late or whatever, and they memorize different things that should go in place of D first, and you have to decide which one to go. I mean, in most cases like this, is pretty simple. The thing that breaks down when you differentiate. Now, if you differentiate cosine 3x, it becomes minus 3 sine 3x. It becomes more complicated. If you differentiate x, it becomes 1. And if you differentiate 1, it becomes 0. This is what's going to break down and become simpler. So for sure, when you have a choice between x and 3, cosine of something, or e to the power of something, we're going to choose x. Okay, but if it's, for example, x and ln x, now ln x, we don't know how to integrate it, so we're going to put ln x in D because we know how to differentiate it. And there you have no choice, and it works out fine because, you'll see some cases like that in the playlist, which will appear, and in the end of the video, somewhere over here, you'll see a playlist for integration by parts and also DI method. You'll see those playlists that you can go and check out, and you'll see some of the other examples. Anyway, so I'm going to choose x as D, and I'm going to choose cosine 3x as I. So here I have to differentiate. So x differentiates gives you 1, 1 differentiates gives you 0, and you stop when you come to 0. Now, sometimes you get something that doesn't stop at 0, and you have to look at that's like other cases that we have to see, which again, you'll see some of those cases in the playlist, which is going to appear at the bottom of this page at the end of the video. Then this we have to integrate. Now, integral of cosine of 3x is the sine of 3x, but divided by 3. So it will be 1/3 of the sine of 3x. Okay, and then the integral of a third of sine of 3x, we have to carry on until it comes to the 0 row. If you integrate sine of 3x, you get minus cosine of 3x divided by 3. So you end up with minus 1/9 times cosine of 3x. Okay, and then in front of the first row, you put a plus. In front of the second row, you put a minus, and you alternate them as far as you need to go. Yeah, we can stop at the 0 here. And then we basically do the following. We multiply this with this and subtract from that. So it's plus this times that, minus 1 times minus 1/9 cosine 3x. And that will give us our integral. So this is going to be, now once we start integrating, we put our square bracket when we have these limits. So I'll have x times a third sine 3x, which is a third times x times the sine of 3x. Then I have minus, and then I have minus 1/9. What happened there? I don't know. That was weird. Minus 1/9 times the cosine of 3x, and my limits are between 0 and pi over 6. Okay, so now we can simplify this, and when we finish, we've got an answer. We have to then evaluate with these values. So this is fine as it is. I'll just simplify. This is a third sine of 3x, and this minus and minus gives you a plus, and this is 1/9 cosine of 3x. We have a limits of pi over 6 and 0. So now we put the limits in now. So we're going to replace. Be careful. I almost made a very bad mistake there. It's a third x here. A third times x. In fact, I'll move this out of the way so that doesn't interfere. Okay, so that's a third x sine 3x. Right, now I can replace the pi over 6 with the x with the pi over 6 first. So I have a third times, I'll put this as pi over 6 times the sine of 3 times pi over 6, which is going to be pi over 2, plus we have 1/9 times the cosine of 3 times pi over 6, which is pi over 2, minus, and now in P2, many a time you put 0 into the expression, it's going to become 0. So a lot of students are used to putting, forgetting about the 0, because normally integrals in P2 are just involving x's, x squared, things like that. Expressions, which involve x, and a lot of times it ends up becoming 0 when you put 0 in it. Okay, although not all the cases. But here, when we're doing further integration, we're dealing with things like cosines and e to the power of x and different types of functions, which when you replace, when you find 0, or you find like cosine of 0, e to the power of 0, they don't give you 0. So you have to be careful. You should always check to see, is it going to give me something? And, be very careful about that. Some people, they just assume it's going to be 0 and they don't even bother putting it in. You should always put it in. In this case, the first term is going to be 0 because you have a third times 0. So whatever comes next is going to be 0 anyway. And you have sine times 3 times 0, which is also 0. So that's going to become 0. But the next term, you have 1 over 9 times the cosine of 3 times 0, which is 0. Now, cosine of 0 is 1. So that's going to give us 1 over 9 over here, right? So you've got to be careful. So now let's calculate all of this. That's going to be pi over 18 times 1. Okay, this is times 1, because sine of pi over 2 is 1. And you got plus 1 over 9 times, and cosine of pi over 2 is negative 1. Put in your calculator, find out, but you should know from your curves. Cosine of pi over 2 is 1. Cosine of pi over 2 is 0, sorry. 0, not minus 1. That's cosine of pi. So always think, use your calculator or think about the graph. That's going to be 0. Cosine of pi over 2 is 0 minus, now the first part is going to be 0, but cosine of 0 is 1, as you can see. So this is going to be 1 over 9 here. Okay, so we end up with pi over 18 minus 1 over 9. So you end up with pi over 18 minus 1 over 9. We can write this as 1 denominator over 18. That'll be pi minus 2 over 18. And there's the answer. If you leave it like this, is also fine. Okay, so that's how we integrate by parts using the DI method. So this is basically integration by parts, and it is acceptable in the exam. You'll see the mark scheme even shows this method as well in the notes. It says, tells them to look out for this alternative, basically layout. It's the same thing as integration by parts. Now what I'm going to do now is I'm going to go through the same question using integration by parts in the traditional way, just for those people who prefer to do that, just to make sure that everything's clear for all of you. So I'm going to now go through the same question, but using integration by parts. Okay, so now, integration by parts, as you'll see in the formula sheet, you have a particular formula, which is as follows. It says the integral of u dv dx with respect to x is equal to uv minus the integral of v du dx. Okay, so this is a formula which is in the formula sheet. What does it mean? Basically, u is the product that differentiates, and dv dx is the product that integrates. So you got to choose one of them as u, which again, the same reasoning goes behind it, that it's the one that breaks down. And the other one is going to be the other product, in this case is cosine of 3x. And we got to find du dx. Now du dx is going to be 1 here. And we got to find v. So here so in this case we have to differentiate. In this case we have to integrate. So the integral of cosine of 3x, if you integrate cosine of something, it gives you sine of the same thing, but then divide by the differential what's inside. So it's going to be a third times the sine of 3x. And then we apply this formula, which is really easy actually. It's just basically u times v, so it's this times this, minus the integral of these two. Okay, so it's kind of like very similar to what we did up there. So anyway, so we have that's going to be equal to x times a third sine 3x. So that's your u times that's your u times v. So it's going to be a third x times the sine of 3x. I'm going to have minus, okay, it's always minus these two multiplied. So it's going to be minus the integral of these two multiplied, minus the integral of v times du dx. So it's v times du dx, so it's a third times sine 3x times 1. Okay, so if you want to, you can write the third out here, constant out here, sine of 3x, and that's with respect to x, and we have our limits of pi over 6 and 0. So we have to integrate this part now. Okay, this is a third x sine 3x, and this is minus a third, and this, if you integrate the sine of something, it gives you negative cosine of the same thing, but then divided by the differential of 3x, which is 3, and that gives you, these are limits. Now we can calculate it. So basically, I'm going to just stop here because it's the same now. So you have a third x times sine of 3x plus 1 over 9 cosine of 3x, limits pi over 6 to 0. Okay, and we can see that I've already shown up to there. We had exactly the same thing. A third x sine 3x plus 1 over 9 cosine 3x, limits of pi over 6 and 0. This one just seems a lot more user-friendly, that's all. But it's the same thing. Basically the same thing that we've done. Okay, so there we have the answer. Okay, I'm just going to write down the answer because the rest is the same exactly as before. So we end up with pi minus 2 over 18. Pi minus 2 over 18. Right, now, I'm going to first show you a little trick that will help you to check your answer in case you made a silly mistake using your calculator. Of course, you can't just do this and expect to get the full marks, all right, to get the marks at all, in fact. But you have to, or you can check if you have time, especially. You want to make sure you didn't make a silly mistake, which is easy to do in an exam. So we have x times cosine. So I use the integral button with these two limits times cosine of 3x. And I use this x from the button over here in this type of calculator. So I put the expression in, and now I've got to put the limits in, which are 0 and pi over 6. So I've got to do pi over 6. All right, I have to make sure that I'm in radian mode, which I am. And I press equals. Now it's going to give me a decimal value, okay, which is 0.06342. Okay, so I can write that down here just to 0.06342. Now, I'm going to check my answer that I got when we calculated it. I'm going to verify that they're the same decimal value. So pi minus 2 over 18 gives us exactly the same answer. Okay, so we can verify that we've done the right thing. Okay, so that's a little way you can check. Now, okay, so here we have an extract, this is like a screenshot from the mark scheme, the official mark scheme of this paper, and in the notes it mentions that, you know, alternate methods may be seen, e.g. D and I method. So it's shown this method here. So basically, sometimes it's called the tabular method. So it's an acceptable form of integration by parts. It's absolutely 100% acceptable to use the DI method in such a question. No doubt about that whatsoever. A lot of students have doubts about this, but don't worry about it. It's absolutely acceptable in the exam, so that's fine. So other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of integration from P4 you'll find in the playlist down here, and then in particular I'll have especially integration by parts Okay, and another one specifically for the DI method as well. So you can have a look at other examples of it as well. Thank you for watching and see you soon.